Hey, third hour. So I totally miss you again. I'm sorry that I'm not in class, but I had to take Link Crew somewhere today. So here's the deal. In your notes, we left off where we have to find the expression for the perimeter and area of the rectangle. So let's take this rectangle. Now, if you think about it, remember that area is length times width. Okay, so if I want to find the area of this rectangle, I'm going to take the length times the width. Or in this case, I can just put the 3, I'm going to do the 3 first because it's smaller, and then I have to multiply that by the m minus 7. Now when I multiply those, this is really just distributive property. So I would go 3 times m is 3m, and then 3 times negative 7 is negative 21. Okay, so that would be the area of the rectangle. I don't know what m is, so I have to leave it in terms of m as the variable. So that would be my area. And then remember, perimeter is twice the length plus twice the width. Okay, so if I want to find the perimeter, I'm going to take twice the length. So I'm going to go 2 times the m minus 7 plus 2 times the width, which is 3. So now I've got to distribute here. So I'd have 2m, and then 2 times negative 7 is minus 14, plus 2 times 3 is 6. And then the last part would be to combine like terms. 2m, that doesn't have a like term, so I'm just going to bring that down. But negative 14 and positive 6 are like terms. Negative 14 plus 6 is negative 8. So that would be my perimeter, 2m minus 8. Let's do another one. Okay, again, area is the length times the width. So I'm going to take the small one. I'm going to take 7 times 10 minus 3g. All right. Now again, we have to do the distributive property. 7 times 10, 70. 7 times negative 3g is going to be negative 21g. And that's going to be my area. I can't go any further. There's no like terms to combine. So that would be it. Now we'll do perimeter. Again, we take twice the length, so I'm going to go 2 times the 7 plus 2 times the width, which is 10 minus 3g. Now to go from here, 2 times 7 is 14. Okay, now we've got distributive property. Positive 2 times 10 is plus 20. And then positive 2 times negative 3g is minus 6g. All right. Now we combine like terms. These two in the front, 14 plus 20, those are my constants. So I'm going to go ahead and add those together. 14 plus 20 is 34. And then minus 6g is just going to drop down. So that is my perimeter. One last one. Area. Again, I'm going to take the small side, so it'll be 6 times the 2m plus 11. Okay? Now we distribute. So area is going to be 6 times 2m is 12m. And then 6 times positive 11 is plus 66. And that's going to be my area. Then we do perimeter. Perimeter is twice the length. So for this one, I'm going to go 2 times 2m plus 11 plus twice the length, so it would be plus 2 times 6. Again, going back to the beginning, first we have to distribute. 2 times 2m is 4m. 2 times positive 11 is plus 22. Plus 2 times 6 is 12. And again, combine like terms. 4m is by itself. Positive 22 plus 12 is plus 34. So there's my perimeter. All right, so that's just a quick way to do area and perimeter using distributive property. Making math easier, okay? We can use distributive property to make math a little bit easier. When I have 6 times 49, I can make this a little bit easier. Let's turn this 49 into 50 ones, because 50 is a little easier to work with, okay? So I'm going to change that 49 to 50. But I can't just change it completely. It still is 49 right here, okay? But 50 is a little easier to work with. So I'm going to change this to 50 minus 1, okay? And this is actually something that you can start thinking about and doing in your head as time progresses. But for now, just think of it, 50 is a little bit easier, but 50 minus 1 gets us back to the 49. So now you can use the distributive property to solve this. First, you'd take 6 times 50, okay, and that's going to be 300. That you could do in your head. And then you take 6 times negative 1 is minus 6. That leaves us with 294. Okay, that's a little bit quicker way that you could actually do this in your head using distributive property. And for now, you may need to write it down. That's fine. But it does make it a little bit easier. Okay, moving to the next one. Negative 3, instead of 199, 200 is a lot easier to work with. But then again, I'm going to have to subtract the 1 to get me back to the 199. So now if I distribute, negative 3 times 200 is negative 600. Okay, then we take negative 3 times negative 1, that's plus 3. Negative 600 plus 3, remember those are opposite signs, so we actually subtract them. We'd get 597, and the sign is going to be negative because the 600 is bigger and it's negative. Next one, 7 times 203. 200 is really close to 203, and it's going to be a lot easier to work with. But I don't want to change this number completely, so I'm going to go 200 plus 3. Okay, so that's still 203, it's just these numbers are going to be a little easier to work with. 7 times 200. Well, 7 times 2 is 14. Bring over the 2 zeros. And then 7 times positive 3 is plus 21. Now that we can add up pretty quickly. 1,421. Number 9. Not number 9. 9 times 54. This one you can go a couple different ways. You could go 50. You could go 60 and subtract. However you really want to do this one would work. I'd probably use 50. But then I'd have to add 4 to get back to the 54. So now we take 9 times 50. 9 times 5 is 45. Add the 0. 9 times 4 is plus 36. Okay, now 450 plus 36 is a little easier to do in our head. 486. Pretty cool. Okay, let's turn this into a real life situation. I've got 3 Ds for 3 CDs at $12.99 each. Okay, so I'd have to take 3 times $12.99. But instead of $12.99, what if I change this to $13? And then how would I get back to $12.99? I'd have to subtract a penny. Okay, make sure you write this in terms of dollars and cents. Now, what is 3 times 13? Well, that's 39. Then, what's 3 times negative 0.01? Okay, well, that's going to be negative. Now, just think of it. What's 3 times a penny? It's 3 cents. Okay, so it would be 0.03. What's $39 minus 3 cents? Well, that would be 38.97. Okay, real quick, nice and easy. Dollar problem. Okay, 4 pizzas at $4.98. Again, I would take 4 times, instead of using $4.98, I'd use $5. But to get back to the $4.98, I'd have to subtract 2 cents. Okay, $5 minus 2 cents gets me back to this $4.98. Now we'll distribute. 4 times 5 is 20. And then 4 times negative 2, that's going to be negative 4 times 2 cents, that would be 8 cents. So it would be 0.08. 20 bucks minus 8 cents, 1992. That's a cool, real-life problem we can use distributive property for. So next time you're at the pizza shop, you'll know exactly what to pay by using distributive property in your head. How cool is that? A local sports store is selling its hiking socks for $2 off the regular price of a pair of socks. You buy 3 pairs of hiking socks. Write an equation that gives the total cost T as a function of the regular cost R of a pair of socks. Then find the total cost if the socks regularly cost $10 per pair. Well, the first thing we're supposed to do is write an equation. So let's start there. So I'm going to have total equals. Okay? Now, I started off with a regular cost, but now we're also buying 3 pairs of hiking socks. So I'm going to take 3 times my cost. Okay? Well, we had a regular cost that you would normally pay, but the hiking socks are $2 off of that, so it's going to be the regular cost minus the $2. Okay, so regular cost minus the $2 for the cost of a pair of socks, but we're going to buy 3 of them. All right, so now that we have this equation, we want to find the total cost if the socks regularly cost $10 per pair. Well, if the regular cost is $10, all I need to do is take that $10 and plug it in for regular. So I'm going to go T equals 3 times 10 minus 2. Okay? So first I do what's inside the parentheses, so it would be 3 times 8, which is going to be $24. Okay? That would be my total cost, and that's my answer. A department store is selling its plastic shoe boxes for $1.50 off the regular price. You buy 4 shoe boxes. Write an equation that gives the total cost T as a function of the regular cost R of a shoe box. Then find the total cost if the boxes regularly cost $3.59 each. Very much the same type of problem we've got going on here. Total cost. The pen's a little slow today. Total cost equals, we're buying 4 shoe boxes, so it would be 4 times the regular cost, and it's $1.50 off, so I'd have to subtract 1.5 from the regular cost. Okay, so regular minus 1.5, $1.50 off the regular cost, and we're buying 4 of them. Okay, now it says we'll find the total cost if the boxes regularly cost $3.59. So I'd go 4 times 3.59 minus 1.5. I'm going to go ahead and use the order of operations again because I like it better. So it'd be 359 minus 1.5. Well, that's going to be 2.09. Okay, now there's a couple ways you could do this. You can multiply this out just the way it is, or you could use that just cool making math easier thing that I just showed you, where you could take 4 times $2 is $8, plus 4 times 9 cents is 36 cents. So it'd be $8.36. No matter how you do it, if you did it on your calculator or if you did the distributive property in your head, either way, $8.36. Sweet, cool. Okay, so you should have the equation to start with because they asked you for that. And you should have the total cost when we find out the regular cost. Okay? So that's how you would do those word problems using distributive property. All right? Now, please, if with the rest of the time you have remaining in class, work on page 99, numbers 1, 40 to 42 all, 44 to 46 all. And I will see you tomorrow. Have a good day.